My name is David Choi, and I study the weather on giant planets. When we look at Jupiter, we're seeing the top of its atmosphere and its weather layer. And its weather layer contains a lot of interesting features such as jet streams, vortices, storms, and these particular features called hotspots. So hotspots are like holes in the clouds because they appear very dark when observed in visible light, but in near-infrared light they appear very bright. This indicates that we're seeing deeper down into warmer layers of the atmosphere. Hotspots have been previously studied by the Galileo Atmospheric Probe. In 1995, the spacecraft released a probe that descended into Jupiter's atmosphere, specifically at a hotspot. And this probe made the first in situ measurements and the only in situ measurements of Jupiter that exist today. So it's very important to understand how hotspot meteorology works in order to place these in situ measurements from the Galileo probe in its proper context. In 2000, the Cassini spacecraft flew past Jupiter and created a series of still images that we compiled into time-lapse movies of Jupiter's atmosphere. Using these movies, we observed Rossby waves that caused north-south meanders in a jet stream south of the equator. With new movies, we instead focused on hotspots. Hotspots are unique because we believe that there is a Rossby wave similar to what we previously detected, but instead of this Rossby wave moving north-south, it primarily moves up and down in the atmosphere. The downward portion of the wave pushes air down into warmer layers of the atmosphere. This causes any clouds that are embedded within the wave to evaporate and prevents further clouds from forming. So at any given time, there are approximately 8 to 10 hotspots in Jupiter's atmosphere that are spaced roughly evenly apart from one another. We believe that each of the downward portions of this Rossby wave corresponds to the hotspots that we see on Jupiter. This new finding is exciting because it'll allow us to re-examine the Galileo probe data and allow us to better understand it and better place it in the context of Jupiter's overall global climate and atmosphere.